Want to nail engineering manager interviews at Mang and other top-tier companies? You can with USA's #1 tech interview prep platform. We have 300 plus SMEs and instructors from top-tier tech companies to help you land your dream job. We've helped thousands of engineers make their way into Mang. You could be next. To learn more, register for our free webinar.
I don't think we've met before, so can you tell me a little bit about yourself?
Sure. Yeah. So I'm currently a full stack software engineer. I've done some work on the front end, building out NPM packages. I've also worked on the back end, working with message queues and state machines. And yeah, my goal is basically to up level and to work for a FANG company. I want to specialize on the front end section mostly. So yeah, that's a little bit of a background on me.
Well, thanks for telling me about that. And can you tell me a little bit about your experience with Interview Kickstart so far? That as well.
I've worked through all the coding sections. This is going to be my last one on dynamic programming. So this is my 5th interview. After this, I still have to do the behavioral and the front end specialization piece of it. So yeah, hoping to be interview ready in hopefully 2 to 4 weeks. And so far, I've loved the program. It's benefited me so much. I've learned so much from it.
Oh, that's good to hear. How have you liked your previous mock interviews?
They've been very helpful. Every single one of them have been very insightful, and I like that the interviews are problems that I haven't really seen in the practice problems, so it throws me off a little bit, which is good. So I do appreciate that.
Cool. Yeah, thanks for telling me about that. So we're going to be doing a dynamic programming related interview today. I want to spend somewhere around 35 to 40 minutes to simulate a real interview. And then in the remaining time at the end, we can discuss solutions and feedback.
Okay, sounds good.
Yeah, looks like you've joined the code bunk already. So can you share your screen with the code bunk and then we can get started? Sure. All right. So to set up the problem, I'd like to describe the rules of the game. So imagine suppose I'm thinking of a number from 1 to 100, and you have to try to guess what that number is. But every time you guess incorrectly, I will tell you whether my number is higher or lower than what you guessed. So if you wanted to guess my number as quickly as possible, how would you do it?
I would use binary search for that. Basically looking halfway at the middle point in between the highest and the lowest, and then if it's greater, then I'll look in the halfway point from that middle point up into the highest number.
Yep. Now let's say that instead of trying to minimize how many guesses you make to get to my number, suppose that you have to pay a penalty. So every time you guess wrong, you have to pay whatever amount that you guessed in dollars.
Oh, interesting.
So if you follow your strategy and you guess 50 first, then you pay $50 if that were wrong, and you still want to get to the number that I'm thinking of, but you want to get there not in the smallest number of guesses, but paying the smallest amount of penalty. So in that case, I'd like you to write a function that calculates what's the smallest amount of total penalty you can pay in order to guess my number correctly eventually. So the function's input is just going to be the maximum number in the range, 100 in this example. The minimum number is going to be implicitly 1.
Okay. Yeah, that makes sense. Is it okay if I write down some of those rules here in the comments?
Yeah, please do.
Okay. So the range is from 1 to 100. Could I assume that, or could it be a bigger range than that?
So the input to the function is going to be wherever the maximum end of the range is.
Got it. Okay. So let's say 1 to n. And then we want to minimize the number of guesses. And each guess will cost us the amount that we choose. All right. So then an example input. Let's just say the range is 100. And then the guess that we want is, I don't know, we'll say 10.
Okay.
Okay. So for this, I would like to treat it as a recursion, a recursive call first, just to kind of see how that recursive tree would look. Because if I'm
Yeah.
finding that there's a lot of replication calling the same number, then hopefully we could catch that using dynamic programming.
Okay.
So then the first call would be basically n, which is 100, and then 100. Yeah, I'm getting a little stuck trying to see the recursive tree, how it would go. Using binary search, I would say it would go from 100, and then it would go to the midpoint, which is 50, and then 50 would either go, if the goal is higher or lower, it would either go to half of that, which is 25, or it would go to 75.
Mhm.
And then, yeah, it would just keep going halfway point until it's either reached the goal or it's reached 0.
What do you mean by reaching
So in that
0?
case, um, yeah, so I'm thinking if it's reached 0, then it wouldn't have, it didn't find the goal number, so it should stop trying to. It's basically the base case of the recursion. Or if it found the goal,
How
that
can
would
you
also be the
how
base
can you
case.
not find the number?
If you're cutting it in half and basically you get to below 0, you get to 0 or less. So that would
No.
indicate that going down the left tree by going half of 50 or half of 100 to 50 and then half of 50 to 25, that would indicate that the answer lies above 50. So going down the left subtree would not be the goal there.
No, I don't see what you mean by that. How could you go down to 0?
So if I was doing a binary search and I kept cutting the input in half, basically, so I could either go to the midpoint between 0 and the start. So say, for example, at this stage, the start is 0 and then end is 100. And the midpoint of that would be 50. And then, yeah, since this one, the start is 0 and then the end is 50, it would go down to 25. But then for this one, the start would be 75 and then the end would be 100.
So still not seeing how you can get to 0. But why would the start be 0 in the first case?
Just to indicate what the range is, so that we could find the midpoint to keep cutting the
Right, but why would
amount of
0 be
numbers
in
to
that
look at.
range?
Yeah, that's a good point. It should be 1 then, because 0 is not even an option.
Right.
Yeah, thank you for pointing that out. So I would think that then 1 would be the base case if we reach 1.
If we reach 1,
If we reach 1, or if we reach the goal, then that would be the base case for the recursion to stop.
but you don't know what the goal is, so how would you know? How would you reach the base? How would you know you've reached the base case?
Oh, we don't know what the goal is. Okay.
Right, that's why we're playing this guessing game.
Okay. Okay, in that case, then if we don't know the goal, we're basically going to have to look at every single number and then determine what's the minimum cost to get to each number, the minimum number of guesses to get to that number. And then, since we'll have the cash values of how much cost it is for each value, then at the end, we could basically, once we know what the goal is, we could just point out how many guesses it took to get there. So
What does that have to do with the problem that we're solving? The number of guesses?
it basically will, so we won't be caching the number of guesses, but we'll be caching the cost for each guess. What's the minimum cost? So I'm thinking of having a cache that would basically keep track of the cost for each input. So it would start with
Okay.
100 and it would. Sorry, go ahead.
Yeah.
You're going to say something?
So when you say the cost for each number, wouldn't just be the number itself? Or am I not understanding correctly what you mean by the cost?
Yeah. Let me think about that. Yeah, it'll be the cost of the number, but then maybe also the cost of the previous numbers that it took to get to that number, or the cost of all the previous guesses. So each guess, what was the number that was chosen in that guess, that would add up to the cost of the next number. So for example, the cost of choosing 1 would be 1. So if I had an array and then basically index 1 would be 1 for guessing 1. But then if I were to guess 2, so the minimum cost would obviously for that one be 2. If we just pick 2 directly, I guess I'm having trouble understanding how the guesses work.
Right? What are you having trouble with?
Just trying to see like the ways we can get to the number 2. So we could get to number 2 by just guessing 2, but then is there any other guesses that would lead us to 2? Because if not, then the minimum, like you said, the minimum is always going to be that number.
Well, any sequence of guesses could lead you to 2, depending on whether the person says higher or lower.
Right. Where does the higher and lower come in? Is that an input?
No, that's part of the rules of the game.
Yeah, can we go over the rules of the game again, please? So we have a range, and then how am I supposed to know if I reach the goal?
Not sure what you mean there. You don't know what the goal is. So the
Yeah, so how do I know if I got there? Like, is there a way that
well, you will get there eventually because it's guaranteed to exist.
it seems like there's some missing information there?
What information do you think is missing?
To know when I've reached an answer. Could you provide an example output, please?
Okay. So if the input is 100, the output is it's going to be pretty large. Let me see.
Okay. Maybe we could use a different input? That'd be more helpful.
So the output ends up being 400. But
400,
yeah, we
okay.
should try a smaller input. So if the input is
Okay.
10, then the output is 16.
Yeah, I'm trying to understand how input 10 got to 16.
Oh, I can explain it. So the best strategy is to guess
Okay.
7 first. Then if the person says
Okay.
higher, then you guess 9. And then
Oh, I
so
see.
at that point, the person says higher or lower, then you'll get the next guess correct. In which case you've paid 7 plus 9 as penalties. Now
Ah,
suppose you guess 7 and the person said lower initially, then well, what would you guess then?
I guess like 5 probably,
Uh,
or somewhere in between
yeah,
1
let me actually
and
run
7.
my code and see what it would be.
Okay. So yeah, I guess that's the part that I'm stuck on, is where does the higher and lower come into? Are those inputs?
Um, no,
So then how would I know to go higher and lower?
well, the, you need to provide a number of dollars that guarantees that you win the game no matter what the result is.
Okay. Okay. I see. Okay, so then the cash would basically include both options if I were to go higher and lower at each guess, then I would think.
All right, so I just ran my code for the example and found that uh, if the person says lower when you guess 7, the next guess should be 4.
4, okay, thank you. Okay, so then I think that's actually the recursive tree then. It would start at a number and then it would either go higher or lower. And then the cache should keep track of the minimum cost of going higher or lower. So for example, if we went to 7 and then it was higher, it got to 9, and then if 9 was higher, it would be 10 because that's the only other option. And then if 7 was lower, it would go to 4. And then if it got higher, it would go in between 7 and 4, so like 5 or 6.
What would you
And
guess then?
if it was lower and we went to 4 and then 4 we got higher, I would guess 5 or 6
Mhm.
in between 4 and 7.
Why 5 instead of 6?
I guess it depends if we round up or we round down.
Rounding?
Yeah, it might be better if we go to 6 then, because then we could at least still go lower and we won't miss the 5. If we went to 5, we would miss the 6.
Why would you miss
So it's
it?
almost, we would miss the 6 because then, so basically the recursive tree, it seems like it would always have like a start and an end. And at this point, so it would come in as 10. So the start would be 1 and end would be 10. Then we come into here, the start would be 1 and end would be 7. And here, sorry, just trying to think about this for a second.
Okay.
Start 1 and end 7 doesn't seem right.
What doesn't seem right about it?
The range of it seems that maybe start should be 7 and end should be 10. I'm just trying to think of a range so that I know that if I have to go higher, this is my limits. I could go higher from here to here, or I could go lower from here to here. So when we're starting, my
Oh,
range is
okay.
between 1 and 10. And
Okay.
then if I were to go half of that, then my range basically becomes,
What do you mean half of that? Like 5?
so well, I meant the first guess. So my first guess was 7. So
Yep.
now I'm trying to think of what would my range be when it's 7. I guess the range would still be 1 to 10 because you could still pick any number between 1 and 10.
I'm not following where that came from.
Well, I'm just trying to think of if I was at 7 and then I was told higher, how would I guess 9? I would guess 9 by knowing I could choose between 7 and 10.
Why would 7 be an
So
option?
or sorry, 8 and 10. So my start would be 8 and then my end would be 10 at this guess.
Okay.
And then if at 7 I was told it needs to be lower, then my start is equal to 1 and my end is equal to 6.
Mhm.
Okay, so if I were to cache this for dynamic programming, I would have to begin if I would need a 1D array or a 2D array. If I did a 2D array, the start and end could be the indexes for the 2D array.
Okay.
So basically the array would be 2-dimensional, and then M would basically be start, and then N would be the end. So it would be a 10 by 10 matrix, basically. And then at each point, I would calculate what's the minimum cost. So at 7, I would basically have to take the minimum of going lower or higher. And then that would be the answer for that start and end index. So let's see.
Well, how do you know that um, how do you know that the right guess is 7?
I don't, but what I could do is cache what was the, if 7 was the right guess, I could keep track of what was the minimum cost to get to that guess from
No, I
going
mean, how
higher
did
and
you
lower.
know that this is the number you want to guess?
Yeah, that I don't know, because it's not provided, right? So I don't think I'll ever know that. I guess I just have to keep track of every number, and then at the end, I'll find out if it was the right guess.
Okay,
Because
what do you mean by the
that's the
right
part
guess here?
that's the part that's unclear to me, is where the what was the right number? What was the goal? What number should I should be stopping at?
Stopping at?
Right, like how do I know 7 was
Well,
the correct number to choose? That's not provided, so I'm not really sure how I would know that.
right, you don't need to know that. You need to write a function that finds the amount. Okay, so first, you're not supposed to know it because that's why we're playing the guessing game. If you knew it, then you would just guess that immediately and not pay any penalty.
Okay, but you're asking me how would I know that? So that's what I'm trying to explain, is I wouldn't know that. So I'm not sure how
Well,
to answer your question
at some
of how
point,
I
you would
would
have
know
to
that.
discover that guessing 7 will minimize the amount of penalty you pay.
So how would I know that 7 was the better choice?
Right.
So I would have to, yeah, basically the caching, I would have to keep track of what was the lowest cost to get to 7. And basically
I
to
mean,
find that, I would have
lowest
to
cost
go
to
from
get to
7.
7.
Yeah, so basically if I were to guess 7, I would have to go higher and lower from 7, and then basically calculate what was the minimum cost to get to 7. To
I
find that, I would have to get
don't
the,
understand what exactly do you mean by getting to? What does the word get mean here?
so in the get would be my guess. If I were to guess 7,
Uh,
what was the lowest amount of guesses to get to 7?
don't know what you mean by that. I mean, don't you get 7 immediately?
You
So the
do get
lowest
7
amount of
immediately.
so the
Yeah,
lowest amount of guesses to get there would be 1. I'm not sure if that's what you meant, but
it would be 1, but so basically when I'm guessing 7, if that wasn't the number, I would have to go higher and lower. So then what I could do is keep track of the minimum cost as I'm going down the tree.
minimum cost of what?
Of either going higher or lower.
Do you have
So
a choice in the
say the
matter?
goal was, yeah, I could go higher or lower at every single guess. So say maybe the 4 was the answer, then I would
Okay.
calculate if I started guessing with 7, what was the minimum cost to get to 4? But yeah, like you said, if I just guess 4 directly, it would just be 1. It would just be 4.
Right. You don't know what the number is.
Yeah, I'm trying to think of how the input of 10 led to an output of 16.
Well, if the number was either 8 or 10,
Uh-huh.
then you guess 7, and then you guess 9. So that's 16. If the number was actually, let's say it was 1, then you guess 7 and 4. And then after, so that's a total of 11 so far. So then you guess 2, and then you guess 1. So a total would be 13.
Oh, I see. Okay. So if the number was 4, I either guess 7 or 4, and then I guess 2. Did I get that correct?
No, you'd start by guessing 7, and then you guess 4, and that would be correct.
Oh, I see. Okay. You start guessing 7 and then guess 4. Okay. So guess 7 and then guess 4 and then got to 1. Okay. But wouldn't it be cheaper if I just guessed 1? Wouldn't that always be the minimum?
So you always want to guess the minimum? Is that what you're suggesting?
No, I'm just trying to think of how I would keep track of what the minimum cost was. And yeah, what you said about if you just directly guess the right number at the very beginning, that would always be the minimum. So I'm trying to think of how I would store that in the cache without just storing guessing that exact number.
Storing what in the cache?
Storing what's the minimum cost to get to a specific number. Minimum cost from each guess.
From each guess? Not following? I thought your cache had 2 dimensions.
Right. So for example, for if 1 was the goal, 7 would be a guess, 4 would be a guess to lead me to 1. So the get 7 as a guess and 4 as a guess, those are the cost. So that's what I mean by guesses is 7 and then 4. I
Why
would
would
want to
that be
get
stored in a
the minimum
cache?
cost. So I could keep track of what's the minimum cost of guesses to get to a specific number.
Is that
So
what
for
a
1, mhm.
cache will usually store in a GP problem?
Yes, yeah. If it's a minimization problem, then yeah, I would store it. What's the minimum in the cache? And this does seem like a minimization problem.
Right. Yeah, so you haven't talked about minimizing anything yet.
Yeah, so the 2D array would basically it would keep track of what's the minimum for each guess with a specific start and end index. That's the direction I was thinking of going.
So where does a guess go?
Yeah, that's a good question. Yeah, maybe the start and end is not the right way to create this table. If I was to just store, so if I were to store one, a minimum for one, if I were to store that here, and we discussed that the minimum was 13, I could store it in a one-dimensional array. But I don't think that's right because you can get to one from different ways. You could get to one from either a higher or a lower guess. So that's why I was
Uh,
thinking that the two-dimensional array makes more sense.
How can you get to one from a lower guess?
Get to one from a lower guess. So if we were to guess 4, then the lower would be 1. But yeah, I guess we can't get to 1 from a higher guess though. So it would seem that 1 is
Oh, I see.
the the base. Yeah.
All right, it's been about 35 minutes, so we can stop here.
Okay.
Uh, yeah, we haven't really made any progress, so I guess we could start with the explanation from the very beginning.
Okay.
So let's work through some smaller examples first. I guess I'll put some notes starting at line 35. All right, suppose n equals 1. We always want to start with the smallest example since that will give us a base case. Then we'll get 0. So what's the logic here? If the min and the max of the range are both 1, then we know the number is 1. So we'll guess that. And the total amount of penalty we've paid is 0. Okay, how about 2? So here we have a choice between guessing 1 and 2. So let's think about what happens if we guess both of these choices. If we guess 1, then let's say the person was actually thinking of the number 2, right? So they'll say higher, and then we'll guess 2 correctly. So the total amount of penalty paid is 1. Right. On the other hand, we could have guessed 2 as well, in which case, say the person says the number was lower, then we'll pay a penalty of 2, and then we'll guess 1 correctly in the next round. So what's our answer here? Well, we want to minimize our penalty, right? So if we minimize 1 and 2, we'll get 1. So the result here is going to be 1. Now let's say the input is 3. So we're guessing in the range of 1 to 3. And we have 3 choices here, 1, 2, or 3. If we guess 1, then the person will say higher. Then we'll have to play the same game in the range of 2 to 3. So let's define a function f. You call it, let's reuse your name start to end. We'll call this the cost of playing the game from the range start to end inclusive. So let's rewrite our let's rewrite lines 40 and 41 first. And n of 3 that's going to be equivalent to f of 1 to 3. Let's actually write it like that. So it's going to be min of 3 choices. If we choose 1, then the remaining range is going to be 2 to 3. If we choose 2, then the remaining range is going to be either 1 to 1 or 3 to 3. And if we choose 3, then the person will say lower, and the remaining range is going to be 1 to 2. So let's figure out which of these is the minimum here. So 1 plus f of 2 to 3. Here, I can use the same logic as with 1 to 2 and say that if I guess 2, well, whichever one I guess, the next guess is guaranteed to be correct. So this could be thought of as min of, so if I guess 2, let's say I pay that penalty, and then the range will be 3 to 3. If I guess 3, and that's incorrect, then the person will say lower, and the range will be 2 to 2. Okay, and we've established that if there's only one number left, then we'll get that correct. So f of 3 and 3 and f of 2 and 2 are both going to be 0. So let's replace those. So this is going to be 1 plus 2 here. So these are both going to be 0. So I guess it's going to be 2 either way. So we're 2 plus 0 or 2 plus 0. And the third choice was if we guess 3. F of 1 to 2 we know from before. We know that's going to be 1. So 3 plus 1 is going to be 4. So the cost of our choices are 3, 2, and 4, which is going to get us a best result of 2. So it's telling us that if we guess 2, then we pay a penalty of 2, and then our next guess is going to be correct either way. Okay, in this case, we didn't know what this or means because f of 1, 1 and f of 3, 3 both evaluate to 0, so we didn't have to choose between them. But in the general case, we do have to choose between them somehow. So let's expand the example more. So what if n equals 4? Then we have 4 choices. So the min of choosing 1, 2, 3, or 4. If we choose 1, then the remaining range is going to be 2 to 4. If we choose 2, remaining range is going to be 1, 1, or 3 to 4. If we choose 3, the remaining range is going to be f of 1 to 2 or f of 4 to 4. If we choose 4, the remaining range is going to be f of 1 to 3. All right, so let's fill these in. F of 2 to 4, that's going to be, so if we substitute in our formula, we get min of 3 choices. 2 plus f of 3 to 4, or 3 plus f of 2 to 2, or f of 4 to 4. And the third choice is f. We guess 4 first, and then the range becomes 2, 3. So this whole thing, we could compare it. We can realize it's a similar situation as f of 1 to 3, where if you have 3 numbers, choosing the middle number seems to be the best. So that's going to be 3 plus f of 2, 2, or f of 4, both of which are 0. So let's replace that expression with just 3. 2 plus f of 1, or f of 3, 4. So let's think, what will cost the most money? If the person's actually thinking of the number 4, then they'll say higher. So we'll pay 2 here. And then we still have to play the game in the range of 3 to 4. And we've established earlier that if there's only 2 numbers, then we should guess whichever one's lower. So in total, we've paid a penalty of 2 plus 3. And then the final number is 4, which we know is correct. So there's going to be 2 plus 3. Okay, so in this f of 1, or f of 3, 4, it ended up being f of 3, 4. How about in line 57? Which one is it? So if we guess 3, if the person says 4, then we'll guess that correctly immediately. But sorry, if the person says higher, we'll guess 4 correctly since there's only one number higher than 3. If the person says lower, then we are playing the game again in the range of 1 to 2, which is a sub problem that we solved before, and the answer was 1. So that would be 3 plus 1. Okay, so what was the pattern here? In both of these lines, 56 or 57, we chose whichever one of these subproblems caused us to pay more. So that would mean we take the max of these two. All right, and then line 58, we have 4 plus f of 1 to 3, which we calculated earlier as being 2. So it's going to be 4 plus 2. So we have the min of 4, 5, 4, 6. So it's going to be 4. So n equals 4 is going to give us 4. All right, so let's write down the logic we've figured out so far. The base case is that if the range has one number, return 0. That can be written as start equals end. Now for the recursive case, we can write it as follows: min cost equals infinity, and then try all the guesses for each number in the range start to end. Our logic was cost for, so let me call this guess. Same function called on max of f start to guess minus 1 and f of guess plus 1 to end. And then just update the min cost. Okay, there you have it. There's our recurrence relationship. And then the function that implements this, I will find that in my notes.
Okay.
All right, so I'll put that here. This is written in Java on line 76. So we have a 2-dimensional DP array. The dimensions are n plus 1 each, since the range of an array is from 0 to that number inclusive. So we need the plus 1 to include that number itself.
Okay.
Then we need to fill in the subproblem and results in the topological order. So the direction of dependencies that each subproblem for a range depends on results of subproblems for shorter ranges. So we can fill in the ranges in the order from shorter to longer. So we'll start with the shortest ranges first with a difference of 1, and we'll increase that difference. Then within the same I guess, range size. It doesn't matter which order we fill those in. So I just arbitrarily start from 1 and increase the low end. So the high end of the range is going to be low plus the difference. And then what I have here is just the logic for the recurrence relationship. We'll try every possible guess and calculate how much the minimum cost of playing the game would be for this guess. So that's the value of the guess plus the max of lower or higher. And then we take the minimum of all those guesses and set that as the result of the subproblem from low to high.
Okay.
And then the original problem was low being 1 and high being n. So we return that at the end.
Okay.
Right. Yeah, so there
Okay,
you
yeah, that
go.
makes
There's the
sense.
full solution.
Thank you. Thank you for explaining that.
So if I had to give you feedback on things that you could do better, I think you had a poor understanding of the problem for the first half of the interview, since you were thinking that the output, so the final number was one of the inputs, which didn't really make sense. So I think that would be good to confirm very early what the inputs and outputs are and what the rules of the game are. I think it would be good to work backwards from test cases, starting from small to high. So remember the first input I explained on line 37 was n equals 1, since that was the smallest possible input. And in all these recursion and DP problems, the smallest possible input gives you the base case. So this was a DP problem. Remember, the way the IK taught to solve these problems was to find a recurrence relationship. And to find a recurrence relationship, you start with the base case, and then you find the recursive case. So working through the smallest possible example is what's going to give you the base case. Then working through examples. So the second smallest example, that would give you probably the easiest recursive case to think about. So that's where I worked through the logic of choosing 1 or 2, right, on line 40 and 41, and seeing which one gives us a smaller amount of penalty paid. That gives us the beginnings of the recurrence relationship. So it reveals that we have to evaluate the choices and get the min of the results of those choices. And from there, the examples for 3 and 4 were just to I guess cover the aspects of the logic that didn't apply to the smaller examples.
Okay.
And once we reach n equals 4, then we have the complete logic where with n equals 3, we didn't know what the meaning of this or was on line 50, since both subproblems return 0. So we didn't have to decide which one it was. But then when we expanded this input size to 4, that revealed that this or that I've written here was the max function.
Okay, that makes sense.
All right. I think that's it. You have any other questions for me?
No other questions. Thank you. Thank you for walking through this. I appreciate it.